something strong, you'd think of steel. For centuries, it's been the heavyweight champ of metals. But what if you could make something that's strong like steel? Magnesium alloys are certainly light, and until recently, not considered to have steely strength. But breakthroughs in how magnesium alloys are created may soon change that. To understand the challenges that magnesium alloys face, it may be worth a trip back in time.
What steel did was it allowed cities to build up in terms of skyscrapers, and it allowed the nation to build out in terms of steel rails. And what steel was a strong and flexible substitute for iron in terms of rails and for brick and mortar construction in terms of buildings. So what steel allowed was this growth of the nation's infrastructure in a relatively rapid period of time, roughly from the 1850s and 1860s up through the 1890s.
So we could say that steel quite literally rebuilt the United States after the Civil War and created innovative industrial processes. Take your standard automobile. Steel makes up about 65% of its parts, and for safety, that's important. But reducing a vehicle's overall weight can improve its fuel efficiency. Magnesium alloys are both strong and light.
You want to use steel in very specific locations, like right around the passenger compartment, but there are a lot of applications where you don't need the high strength. For example, you may want the hood of your car to be very lightweight but not very strong because you want basically that part of the car to maybe crumble and then crash, for example. And magnesium is really good in crash worthiness and crash resistance.
Magnesium alloys are also used in aerospace. Planes, helicopters, missiles all have magnesium alloy components.
So the biggest benefit to magnesium alloys is that they're lightweight. So any applications where you need low density or something that's not as heavy, you'd want to use something like magnesium. It is the lightest structural material that you can make something out of. So this is aircraft, like airplanes and helicopters, or vehicles on the ground. So basically I have on here, on this table, two different materials. One is steel and one is made out of magnesium.
So do you want me to try to figure out which is which?
Yes. Tell me what you think the difference is. They're both the same size, so it's not size.
Oh, wow. This one's much heavier. I'm gonna guess this is the steel?
Yes. And the other one's magnesium, and magnesium is about 70% lighter than steel, depending on the grade of magnesium and the grade of steel that you're looking at.
So if it's on my car, do I have to worry about it corroding?
You do. So there are two applications where you use magnesium corrosion to your advantage. One is in batteries.
Okay.
And so you can make magnesium batteries because batteries are basically a corrosion cell, or you can use them for medical applications, and that's what the next generation of magnesium alloys are being used for, is to put into your body and dissolve in your body, basically corrode inside of your body.
So what type of an application are you talking about?
So there's the nice thing about magnesium for the body is that magnesium has a very similar mechanical properties as bone.
Oh, okay.
So there are a lot of orthopedic applications that you may want to use with magnesium and not with steel or titanium. Basically, if you, for example, break your bone, as it's healing, the alloy is degrading away at the same rate that it's healing at. So you're not left with any voids or any discrepancies in your bone structure as it heals.
And do you have an example of one of those screws here?
Yes, here is a magnesium orthopedic screw,
oh, wow.
an ankle screw that we developed here at the university.
And what do you see as some of the future applications of magnesium alloys?
Excitingly, last year, the FAA approved magnesium for use in aerospace structures, like aircraft. Before, they were prohibitive because a lot of people were worried about the corrosion and the flammability associated with magnesium. So they've always seen the experiment where you take a strip of magnesium and light it on fire. You think that it's very flammable. But they actually did large-scale tests, fuselage tests, where they replaced all of the seats on the aircraft, which is a major component of the weight of the aircraft, with magnesium. Before, they're made out of aluminum. And basically, they lit the aircraft on fire, one aircraft made with aluminum and one aircraft made with magnesium, and showed that magnesium was no more dangerous than aluminum. So with that, now aircraft manufacturers can actually replace a lot of the seats on the aircraft from aluminum to magnesium.
We've all done that chemistry experiment where magnesium catches on fire quite easily. So why don't I have to worry about flammability in these magnesium alloys?
So the experiment that you did in your high school chemistry lab, you're lighting pure magnesium on fire. If you alloy it by adding other elements into magnesium, it decreases the flammability.
Well, shall we go outside and do our own myth busting with a flammability test?
Sure, sounds great. So we're holding a piece of magnesium alloy, and it's a pretty large piece, next to a camping torch, and we're going to try to ignite the piece of magnesium. And you can see we're going to get it very hot, but it never will ignite because it's such a large piece, there's too much mass. And so the heat conducts away from the hot area to the cold area, and also this is an alloy, so it's very difficult to get this ignited when it's mixed with other elements. In this case, this is a magnesium, aluminum, zinc alloy. So it's magnesium with aluminum and zinc additions.
Anytime that you adopt a new material, it's important to remember that what you're doing is replacing one set of producers, one industry with another. And there's some real human casualties to that. And so that's one thing I think that engineers should think about. But then again, I think another thing that engineers should consider is the kind of greater benefit to society. We're at a period in human history right now where we're very interested in fuel economy. We know that fossil fuels are not unlimited. We know that there's a great cost to society in burning fossil fuels. And so magnesium alloys have kind of risen as one potential solution in making planes lighter and making automobiles lighter and allowing for that fuel economy. And that's a different way of thinking completely from the way that Americans thought about materials in the 19th century, where you're more interested in making them in bulk, you're interested in making them cheaply, and you're not all that concerned about fuel economy. So it's important to think about magnesium alloys and their lightness as a kind of product of this particular moment in time.
How do you envision these magnesium alloys are going to be used in the future?
Magnesium is very nice for its radiation properties as well. So we have projects where we're looking at replacing a lot of components on an aircraft with magnesium, and it helps to protect the aircraft members. For example, if you're flying between the United States and Europe, there's a fair amount of radiation that you're exposed to as an aircraft crew. If you replace a lot of the components with magnesium, you get less dose of a lot of the radiation that you see flying on an aircraft. What we'd want to use magnesium for in the future is basically replace everything that's aluminum and steel. And we want to manufacture it just like we manufacture aluminum and steel. That's the cheapest way to go. If you try to roll magnesium like you roll steel, magnesium will tend to tear because of its properties. Its properties at the crystal structure level. And so if you roll the material, it tears apart and you can't make anything into sheets. And you want to make magnesium into sheets, especially in automotive applications where you want hoods and door panels, which are usually sheet materials, to be made out of something that's lightweight.
You're not going to see probably the kind of massive production facilities that, for example, Andrew Carnegie built to produce steel in the 19th century. Instead, probably what we're going to see is more emphasis on research and development, more emphasis on making magnesium alloys cheaply, and of course integrating them into the kind of everyday fabric of life. So it's a kind of smarter way of using materials, and that represents a real break from the Industrial Revolution.
So, you've seen the possible applications of magnesium alloys in everything from transportation to medicine to aerospace. What's your take on how science and society can work together to create a new kind of industrial revolution with new materials that have such wide potential?